Today we're going to talk about enumerations and how they can help us out. Enumerations came about from the need to have a bunch of constants that represent specific data values. Now, with something like this, we can have a series of constants already specified by just having final on a particular value. We give it a name like pi or mole, and then we can use it wherever we want. And there's nothing wrong with that. It works just fine. Where we end up having issues is when we have to specify many, many values. So let's say that I wanted to have a final double ace, and then a final double jack. I want to be able to represent a whole bunch of different cards in a deck of cards, and then I have something like, actually these wouldn't be doubles, these would be ints. Int would be fine. And then I could have a final int hearts, and we'll say hearts gets the value of 1, final int diamonds gets the value of 2. You can begin to see that there's a whole lot of issues with trying to represent different kinds of information simply by using variable names. Enumerations helps to alleviate some of that, but the notation is kind of interesting. So we're going to jump right in. I've got a whole bunch of components that I've taken directly out of my notes and just put them into here. I'm just going to start with the section related to the deck of cards. So the way that we get an enumeration is we have to use the reserved word enum. We give it a name for the enumeration, so I've got suit and rank because I need two parts to represent an actual card from a deck of cards. So I have a 3 of hearts, or a king of diamonds, or a queen of spades, or you get the idea. 2 components are necessary to make up the particular card, so we have one enumeration of suits and another enumeration of rank. Just ignore the coins for a few moments. We'll get to those shortly. The thing to keep in mind when dealing with enumerations is they are classes. They are defining specific classes so that when these enumerations are created, they are objects. Each of the values contained inside the curly brackets are our enumeration constants. Each of these enumeration constants will eventually be a reference variable to other values within the class rank or within the class suit. Granted, they are enumerations, but we are treating them as if they are classes. They are just very special cases. So if we scroll down just a little bit here, I've created an array of suit values and an array of rank values. And what I'm going to do here is I'm just going to exit after I try to print this. There's a couple things that I want you to see right away. I'm going to get the values. There's a whole bunch of different components that are available within enumerations. Let's just take a look at some of the methods available to the enum type. We can compare, we can check equals. Ordinal values represent the actual ordinal position within the enumeration constant. We can get its name as a string. There's also a toString. If you recall, toString is part of the object class from java.lang.object. So that has been overridden here. We can get a list of values as an array of enumeration types, and we can also get the value of. This is just some of the things that we can do. So if I try to print suit values, this is an array. So what I'm going to see is something particularly interesting, right? The typical toString that we would expect. So suit is a subclass of L enumerations, and this is its hash value. Not really helpful at all. So we wouldn't tend to do things quite that way to see what's inside of that particular array. What I'm going to do is I'm going to move this down to here. And what I want you to see now is this new kind of for loop, and this for loop is really helpful. This is what's known as a for each loop. The for each loop allows me to say, and we're just going to read this right across, for suit O in suit values. So for suit O in suit values. I'm essentially treating this as an array of objects whose type is suit. So for every value that's in the array suit values, I'm just going to go ahead and print its ordinal representation. So let's go ahead and try that. Go ahead and run it. Now, I said print O, and their ordinal is whatever their ordinal value is. So spades ordinal is 0, hearts ordinal is 1, and so on and so on. So when I print the object, it's actually invoking the toString. That's not what's really new here. What's new is this ordinal thing. So let's get the ordinal part out of the way. The ordinal is its position where we declared it. So spades is 0, hearts is 1, clubs is 2, diamonds is 3. So from the perspective of the enumeration, it's almost like this is an array of individual reference variables. And that's essentially how we're going to treat it. We can do the same thing with the ranks. So we're going to take and move this down. We'll run it again. Now we'll see we have our suits, but now we also have our ranks. Now there's an issue with the ranks, as you can see. I can't use its ordinal value to represent its value for perhaps like a game of blackjack. Because as we know, in a game of blackjack, the numbered cards are their particular values, but the 10, jack, queen, and king all have a value of 10, and the ace can be used as either a 1 or an 11. So the ordinal values can't be directly used to perhaps implement a game like blackjack, but that's not necessarily the initial point here. All we're trying to show is that I can design something really, really simple, and I hope that that's glaringly obvious here. It took me only this to be able to represent all of this knowledge. And look, it prints them out for me. I don't need a method that takes a variable name or a variable value as a constant. I mean, could you imagine? For each one of these constants, I'd have to say, well, a 1, it would be, I should print out ace, or if it's a 10, I should print out jack. Or if it is a jack, it has a value of 10, or if it's an ace, it has a value. This becomes very complicated very quickly when I have to just deal with a pile of variables. Enumerations solve a lot of problems. So it may not necessarily be obvious right now, but I hope that very, very soon you begin to see the power and flexibility that's in these enumerations. These actually were not available in Java until Java version 5, so JDK 5 or Java to SE 1.5, depending on your version nomenclature. They didn't exist until then. It's kind of funny to think about how long Java went without these things. But we've got them now, and everything is wonderful. So let us now take a look at the next section, which is the enumeration for coins. All right. This enumeration for coins allows us to specify some deeper meaning to all of it and can be applied to our ranks. But I wanted to start with something simple. Again, this is directly from the notes. There's a lot more example code for all of this in the notes. I just wanted to go a little bit deeper into the definition of enumerations and how they work. Now, as you recall, all classes have a default constructor. So since enumerations are technically types of classes, you can imagine that for each one of these, there was a default constructor, because how else would I be able to represent this name down here and this ordinal value? There has to be some default constructor that's being used on the back end to populate all of this knowledge. And that's great. I didn't need to do anything with that. However, sometimes I need to be able to represent specific values when dealing with enumerations. So what I'm doing here is I'm saying penny and then parentheses 0.01 because a penny is 1/100th of a dollar, a nickel is 5/100ths and a tenth and a quarter and half of a dollar, right? All these are particular values. What I also want you to see is that this is an invocation to a constructor, all right? It's an invocation to a constructor. So when penny is created inside the enumeration coins, it's actually going to invoke this particular constructor right here. And you'll notice it's a constructor. It's private. Its name, right, matches the enumeration, which is what all constructors do. Constructors in a class match the name of the class. I can pass in a value, and constructors don't have return types. So everything about this particular piece of code is a constructor. Now, constructors usually mean that there are instance variables that they tend to work with. And here is my instance variable, private final double value. So since all of these have ordinal types, so penny would be 0, nickel would be 1, dime would be 2, again, we start to run into that problem that we had back here with our constants. We have ordinal values, and then there's other values that we want to be able to associate with them. The enumeration allows us to do it directly, because now I'm going to say, yes, I know the penny has an ordinal value of 0. However, I want it to represent 1/100th of a dollar. I know that a nickel has an ordinal value of 1, but I want it to have a value of 5/100ths of a dollar. And the same with dime and quarter and all the way up to half dollar, where I could say, yes, I know that its ordinal is 4, but I want it to represent 50 cents, right? 50/100ths of a dollar. So I'm just going to store that in value, keeping in mind that just like with regular classes, every instance of a class, meaning every object that we create for that particular class, has its own set of instance variables. That's what value is here. So value, we'll get a particular value that's passed in as this, right? 0.01 or 0.05 or 0.50. That comes in here, and then we just take that value that's passed in and we put it into the instance variable for this object. And then, of course, we have an accessor. We need an accessor to get the value out of each of these different objects because it is listed as private, and generally speaking, when we go through the trouble of creating objects in the first place, the instance variables are typically private because we want to impose a set of rules and some order on how things are accessed. So now let's go a little bit further down. I'm going to comment this whole section here so that we're only dealing with the coins. So what I've done is I've created another array called coin values. Let me clean up my output here. Created another array called coin values, and it's just an array of coins. And all I'm doing is I'm getting every single coin out of the enumeration with coins.values. Then I'm going to say for coins O in coin values, remember this is a for each loop. I know it's new, but it's pretty powerful, so I want you to get used to using this. For coins O, so this is my loop control variable O, in the array coin values, then I want to do system out println, show me the coin. So it's going to print its name, penny, nickel, dime, quarter, half dollar. Its ordinal is this ordinal value, and the value is whatever, portion of the dollar we have assigned to that. So we're using our accessor method to get that out. So let's go ahead and run that. And we say penny is ordinal 0, which I said earlier, but its value is a penny. Nickel is ordinal 1, but its value is 5 cents. Dime is ordinal 2, and its value is 10 cents. Note the missing trailing 0 on there because it's not necessary. Quarter has an ordinal value of 3, and let's just double check, right? When we look at these ordinal values, right? Penny is 0 because it appears in the first spot. Nickel is 1 because it appears in the second, and then dime, and then quarter, and then half dollar. That's just representing where they're declared in the list of the enumeration constants. So 0, 1, 2, 3, 4, penny, nickel, dime, quarter, half dollar. 0, 1, 2, 3, 4, penny, nickel, dime, quarter, half dollar. And then each of them is getting their specific value that we stored by virtue of the constructor. I know that's kind of a quick overview of enumerations. I hope that it makes sense. If you have any questions, please email me. Obviously, you can view the video as many times as you like. If anything in the video is not clear, just shoot me an email and I'm happy to clarify it. All right, so I want everyone to get this because this is going to be something that you're going to be using in Project 3, and I think that the coins one is going to be very helpful specifically with Project 3. All right, the next video coming up is vectors, which you should be seeing shortly. Talk to you soon.